So now we're going to look at how you can identify strong and weak acids. So we'll see how the behaviour of them differ depending on the different indicators you're going to use. So if we try litmus paper first, okay, so we're going to dip some blue litmus paper into both. Okay, so they are both acids. So they are going to turn both pieces of paper red. So litmus paper is a not very useful indicator in this respect. It will tell you whether something is acidic, alkaline or neutral, but obviously it has no bearing on the pH. So pH paper, slightly more useful. So these acids have the same concentration, but obviously hydrochloric acid is a strong acid, so it's going to turn that universal indicator paper red, whereas ethanoic acid is a weak acid, so it's going to be around 4, pH of 4, and it's going to turn orange. So obviously universal indicator, a little bit more helpful for us here. So electricity, so let's test both of these by connecting them to an electric circuit and see what happens. So hydrochloric is the best conductor, and it's all about that full dissociation or ionisation of the H and the Cl into the two ions. So obviously you've got lots of positive ions and lots of negative ions, so those ions are what is carrying the charge between the electrodes. Okay, if you put it in ethanoic acid, it's only very weakly dissociated, so you're going to get much less of a current reading. So we'll look with magnesium. So magnesium plus acid will make hydrogen gas. So if we put the same piece of magnesium into both, obviously the hydrochloric acid is react much more vigorously because there are many more hydrogen ions available, and obviously the reverse or opposite for the ethanoic acid. So summary then. Litmus paper turned bright red for both acids, whereas pH paper turned red for the hydrochloric acid and pale orange for the ethanoic, which is weaker. We had a bulb glowing brightly with a strong current for strong acid, and a dimly glowing bulb and a weak current for the weak acid, and it was all to do with the amount of ionisation, the amount of ions produced. And the magnesium bubbled very vigorously and magnesium dissolved quickly, whereas we had a very gentle bubbling in the other weak acid.